So morning, today we are doing VLAN and Trunking. Under VLAN and Trunking, I want you to introduce two switches. On your left side, you'll be able to see network devices. Under network devices, you'll be able to see switches and routers. So select switches. Under the switches, I'll drag 2960s to 2960 models, and then I'll go back to a network device on my right to be able to see end devices. I'll select end devices and then drag three PCs. So the first one, the second one, and the third one. So the next step, I want us to rename the equipment. This one is for display purpose. We want to see a well-written or a well documented topology. So I'll open my switch, go to config. I'll open my switch, go to config, and then rename the display name to switch 1. The host name, can still do it from here. It's not the ideal procedure, but I can still be able to do it from here. So I'll say switch display name is switch 1.
But
The
I,
host
I
name,
prefer
the host name, that name is Jones. Host name.
Change the other switch to switch 2, and then save. I'll go to the PC. The PC you don't really need to open it. You can click at the bottom, close to the word PC. The bottom, close the word PC. It will allow you to rename it to PCA, and then the same procedure with the other PC. Close the bottom, rename it PC boy, and then the other one we will call it PC cat. Yes. So those are the devices that we basically have: PCA, PC boy, PCC, and then we have switch 1 and switch 2. So those are the information that we basically have. From there, I want to connect the equipments. So I'm assuming guys have already changed the names of the equipments, or they have already saved the equipments.
Yeah,
done.
So
yeah,
now
continue.
I want now to
Well,
connect the
nothing.
equipment. I'll go to connections. So there's the option of connections. Under connections, I'll select the cable. Which cable is used to connect a switch and another switch? You remember we have several cables. We talked about straight through copper
Cross,
cables,
crossover.
crossover. Like devices, we normally use crossover. So I'll select a crossover cable, connect under F01. I want you guys to use the exact interfaces I'm using because we are going to be playing with those exact interfaces. So from F01 to F01, yes, F01 to F01. So those are the
But then, if I may, Joseph,
yes. So we continue. So
okay.
once you connect switch 1 and switch 2, which cable do you use between a PC and a switch? We normally use copper straight through because they are unlike devices. So I'll connect via F06 to F0. So to fast Ethernet 06 to fast Ethernet, and then I'll do the same for the other PC boy. So F011 this side, and then fast Ethernet. There's a reason why we're using these specific interfaces. So make sure you use those interfaces, and then I'll connect 18. I'll connect 18 to PC to the other PC. So that's what we are doing. So I've connected PCA, PC boy, and PC cat. So from there, the topic, for me to write the topic,
Joseph,
yes, yes.
hello?
Hello, I can hear you. So after assigning those, so I'll go on my packet tracer on top. There is this option that will allow me to add text on my packet tracer, this one. So I'll click on it. So my cursor will change. I'll click on the workspace where I want to write a text. So I'll type VLAN and trunking. So these are the information that I want to add, and then I'll press escape. I can double press escape or else I can change back from my partitions on top. There's an option of going back to cursor. So I can click that option to return cursor back, or else I can just press escape and then I'll lose that ability of adding text. And then I'll drag it to where I want it to be. If I want to edit it, I'll just double click on it and then it will give me the option of editing. So today's topic is VLAN and trunking. So before even dive into the topic, we are supposed to do some few things. We are supposed to assign these devices IP addresses. So I'll pick my text-based option, and then I'll go to PCA. I'll say PCA is supposed to be under VLAN 10, and then the name of the VLAN is student. After student, the IP address it's supposed to have is 192.168.10. What? 10 is something. So this one you can remove it and at 3/24, and then the default gateway for the PC I'll give it .10.1, and then I'll move to PC boy. PC boy also belongs to VLAN 10. The name of the VLAN is student. We shall talk about this. We shall talk about this. This is the documentation so that you guys can have a copy of the information that you're using. 168.10.4/24, and then the default gateway is 192.168.10.1. So those information under PC boy. PC cut. This PC, we shall say it's under VLAN 20. So this one will be on a separate VLAN. We'll call it faculty. And then we shall have an IP address of 192.168.20.3. We can give it 3/24. And then the IP address will be 192.168.20.20. One. So that's the default gateway. So I can just click there, DG, and add that information. No point. Just make the default gateway. Yes. So
Why 20.1, Joseph?
we want to separate PCC. We want to place it on a different network from PCA and boy. So maybe I'm yet to start the class. Okay, what I can say is VLAN and trunking. VLAN basically is the virtual local area network. We want to create an environment whereby different people are using the same physical equipment, but they're getting different services. So with VLANs, we're going to
Okay.
create separate groups. So the first group will be VLAN. For example, the first group can be VLAN 10, and then we can place PCA and PCB, which are the students. They can be on VLAN 10, and then the institution faculty will be under VLAN 20. So we want to separate individuals and place them under different groups. That's the core of this class.
Okay.
Yes. Initially, when we will just assign same IP address from the same network, I mean, not same IP addresses, same network for all the devices, then we won't really need to have groups. And then everybody will belong to VLAN 1. We shall talk about that. So that's what we want to talk about. So just first of all, do documentation, and then I shall explain the topology itself. I'll go to this the switch. If you want to assign it an IP address, so assign the switch an IP address. So we shall say it will be under VLAN 1. Under VLAN 1, IP will be 192.168. It's 10, not the 10. We can give it what? Give it 1.11. We're going to give it 1.11/4, and then this guy we can give it under VLAN 1 again. the VLAN 1. I can use it PLC 1 slash identities. Okay, this is the topology. Are we all done? I want to now start. So, as per the lab that we have here on top, I just want you guys to first of all open your switch 1. I want you guys to all open switch 1 and then move to command line interface CLI. You'll be able to see several options. CLI, and the CLI,
Yeah.
press enter, and the CLI press enter. You will be able to see switch 1 greater sign. Remember, this is the user executive mode. We want to do a show command. This is not the most convenient place to do the show command because it doesn't execute all show commands. So we put a command enable to move us from the user executive to the privilege executive mode. So now this is the privilege executive mode where we normally do the deletes, the saving, and everything here. Right now under this mode, we want to say show what? Show VLAN brief. So we want to play with VLAN. Remember, VLAN is a virtual interface. It's a group that all interfaces on a switch belong to. Remember, in the basic configuration on a switch, we stated we normally assign an IP address to VLAN 1. So the reason why we stated VLAN 1 because it's the group that all the other interfaces belong to. To confirm that, you can press enter, show VLAN brief. Show VLAN brief. So under show VLAN brief, this is what I'm assuming everybody is able to get. You'll be able to see VLAN, name, status, and ports. These are the ports that we have on that switch. We have VLAN 1 and all ports belong to VLAN 1. So we have something extra that we didn't learn in the basic configuration. We have other extra VLANs. So we have 5 default VLANs. So if I was to make notes, this is what I will write. We have 5 default VLANs. We have VLAN 1 where all the interfaces belong to, and then we have VLAN 1002, 1003, 1004, and 1005. So these are the 5 default VLANs. But all interfaces belong to one default VLAN, which is VLAN 1. Everybody under this group should have the same IP address. So for example, our PCA is communicating via F06. It's connected to F06 on this switch. So it means anybody connecting to this switch should be in the same network as PCA, and then they will be able to communicate seamlessly. What do I mean? Look at this topology. Are we all here?
Yes.
Look at
Yes.
this topology.
Yes.
When PCA wants to communicate with PCB, what normally takes place? PCA becomes the source with the IP address of 10.3. PCBoy becomes the destination with the IP address of 10.4. Right now, they are not in VLAN 10. We haven't created VLAN 10. VLAN 10 doesn't exist. They are all under default configuration. And under default configuration on a switch, you've been able to see all interfaces belong to VLAN 1. When PCA is pinging PCB, it's based on IP address. 10.3 is trying to communicate with 10.4. The traffic goes to the route to the switch. The switch, which is switch 1, will request for the MAC address of PCA using ARP, address resolution protocol, and then it will add the MAC address of PCA. So that one you already know. That's the default thing that normally takes place. But that's not what you're focusing on. When the traffic is entering switch 1, it will enter via F06. And when a traffic enters via F06, F06, remember, it belongs to VLAN what? It belongs to VLAN 1. F06 belongs to VLAN 1. The switch will broadcast that traffic to all interfaces that belong to VLAN 1. If your interface is not under VLAN 1, it won't broadcast to that interface. So, if an intruder, if the students and the staffs and the administration are all under the same VLAN, what does it mean? When the finance is talking to the director, his copy of information is usually broadcasted to all interfaces because everybody belongs to the same group. But when we create different VLANs and place people under different VLANs, it will mean the switch won't broadcast to all VLANs. It will only broadcast to that specific VLAN that has generated that information. Hence, we normally place different departments in different VLANs. Talk to me, guys.
The
So we did talk about segmentation
Yeah.
of networks, which is very important. We want to place people under different groups so that in case of an attack or a movement of virus, it would affect all personnel. If it's a broadcast format, it will only affect that group. If there is another broadcast, it will only affect the other
But
group. Yes.
if I may, Joseph,
Yes. So now we have checked. So when PCA tries to ping PCB, I've explained, the traffic will enter the switch via F06. The switch will check. F06 belongs to which VLAN? So F06 belongs to VLAN 1. So it will broadcast to all interfaces that are under VLAN 1. Which other interface on switch 1 belong to VLAN 1? So immediately we'll go to our show VLAN brief and we'll be able to see F01 belongs to VLAN 1. So what are we going to do? So the traffic will be taken to the traffic will be taken to F01, which will slide to switch 2. Switch 2 has gotten data via F01. So switch 2 will check F01 belongs to which VLAN. So we'll open switch 2, we say enable because we don't want to do the show command under the privileged executive. We want to do the show command under the privileged executive. So we shall say show VLAN brief. And the show VLAN brief on this end, we'll be able to see again because the switch is under default configuration. F01 belongs to VLAN 1. So what will happen? The switch will broadcast to all interfaces. So you'll see a copy will go to F018, another copy will go to F011. So there will be two copies because F018 and F011, both of them belong to VLAN 1. So a copy will be sent to 18 and another copy to 11. Once the data reaches PCB, it will check if it's the intended destination, then it will say yes, and then communication has reached the destination. So it will just acknowledge. And the other copy that went to PCC will check the IP address and realize that it's not the intended destination. So it will drop the information. Remember, PCC is on a different network. And our intention was that PCC be under the faculty. So these are instructors or the faculty department. They are getting information that is intended for students. So we want to reduce the traffic that is found on a switch. Remember, a switch is broadcasting to all interfaces. So there was loss of bandwidth as data went via F018. We want to stop that. We want to reduce on the amount of bandwidth being spent locally for in irrelevant communications. So we want to limit, we want data intended for students to be broadcasted to fewer people, to students only. We don't want it to be broadcasted to everybody and then they end up dropping the message. So we want it to be broadcasted to fewer individuals. So the next step is to learn how to create these groups. And then after creating the groups, we move these devices into their respective groups. But before we create these groups, we can now assign IP addresses to these equipments. So the first one, I'll start with PCA. I'll click on PCA desktop IP configuration. PCA desktop IP configuration. And the IP configuration, I'll say 192.168.10.3. That's the IP address of this PC. Tab, it will finish the subnet mask. I'll confirm the subnet mask. Yes, this is the correct subnet mask because you're talking about /24. And then I'll put an IP address for the default gateway, which is 10.1. For now, we don't even need a default gateway. The devices will communicate using IP and subnet mask. Default gateway will be on future, but right now we are not even playing with the default gateway. It's just by the way, so don't panic. I'll do that on PCA. I'll go to PC boy and then do the same, assign IP address PCA and yes, and the other device which is PC. I've written config T to move me or configure terminal to move me from the privilege to the global configuration mode. Under the global configuration mode, I'll say interface VLAN 1. So I'm giving the switch an identity. And the switch, everybody is under VLAN 1. So if I assign an IP address on VLAN 1, I've given the entire switch an identity. All interfaces. For me to access all the interfaces, I'll access them via VLAN 1. So I'll say interface VLAN 1, and then I'll say IP address or IP add. I'll say 192.168.1.11 space 255.255.255.0. Remember it's a /24, and then I'll say no shutdown. Yes, I'll say no shutdown. So please do that. Do that on your side. I'll press enter, please. So interface VLAN 1, assign it an IP address, and then no shutdown. The reason why a switch will work even without an IP address, it will do its functionality. We normally assign it an IP address so that we can call it, we can remotely access it, or we can, yes, remote access. We can use telnet or SSH to reach it. With this IP and subnet mask, I can reach it while I'm on the local area network. If I give it a default gateway, I'll be able to reach it while I'm on a remote network. So yes, so those are the commands that you normally write. And then I'll type end, and then I'll save my work using write. Write is the command for saving. So that's what I've done. Interface VLAN 1, IP address, no shut, and then end. And it will take me back to the privilege executive mode where I want to do my saving command. Saving command cannot be done on the global configuration mode. It has to be under the privilege executive mode. So that's why we normally exit, or end to jump. Exit, it will just move us one step behind, and then another exit one step behind. So it will take a lot of time typing exit twice. So I'll prefer to type end to jump to the privilege executive mode, where now I can write or save. So that's one of the saving commands. I can also say copy running config to startup config.
Right at this. We need to get the copy of the customer, or we are slow. We cannot be. I want to listen to you.
It's okay. It's okay. That's how you say it.
You have to say.
So I'll open switch 2. I'll open switch 2. And the switch 2, I'll type EN, the short form for enable, and then I'll say configure terminal or config T. That's the short form for configure terminal. So because I want to configure at the global configuration mode. Under the global configuration mode, instead of me saying interface, I'll say int. Int is the short form for interface, and then I'll say VLAN 1. So I'm calling out on interface VLAN 1. I'll assign it an IP address. So I'll say IP add. Remember add short form again for address, and then I'll say 192.168. Again 1.12 255.255.255.0, and then I'll say no shut. No shut is the short form for no shutdown. So I'll press enter, and then I'll end. I can exit, but it will take me just one step behind, and then it will force me to exit again, and then it will take me to the privilege executive mode. But if I type end, it will jump to the privileged executive mode, where now I can do my saving command. Remember, we are supposed to do continuous save. If power goes off or my router or switch loses power, I'll be forced to rewrite the commands that are not saved. So if I've done continuous save, I'll rewrite only a few commands, not everything from scratch. Yes. So I'll say write. So mine is saved. So that is on switch 2. That is on switch 2. So because switch 1 and switch 2 are on the same VLAN, and again they're on the same network. They're all under 192.168.1 network. So I'm supposed to be able to ping switch 1 from switch 2. So I'll type ping 192.168.1.11. So I'm supposed to be able to ping my neighbor switch 1. Yes, because we are on the same VLAN, and then again we are on the same network address. So I'll ping switch 1. So that's the first thing you do. So the next step, we want to ping from PCA to PCB because they are on the same network and on the same VLAN. So I'll open PCA, I'll go to desktop, I'll open PCA, go to desktop, PCA, and then desktop as a tab, command prompt, and then I'll say ping 192.168.10.4. That's the IP address of our PC boy. And the results are supposed to be successful. So you'll be able to see send packets are 4, receive packets are 4 again. I'll try to ping PCC, which is on a different network. So I'll try to ping 192.168.20.3, but it's not supposed to go through. Even though they're on the same VLAN, they are on different networks. And a layer 2 devices, which is switch. Two separate networks cannot be able to communicate. So I'll try to ping from PCA to PCC and it won't be successful. So I'll say ping space 192.168.20.3. Even though the code of this lab is to separate packet being received by PCC. PCC will receive this request, but it will drop it. But we don't want our traffic being consumed sending data to this device and it will definitely drop. We want to logically separate these two equipment. So in this scenario, it's just to confirm, even though you're on the same VLAN, if you have different network, you won't be able to communicate. So yeah, do that.
Joseph, from
So after you have tested the pings, so what you're going to do is these are the VLANs that you want to create. VLAN 10, you give it the name of student. VLAN 20, and you give it the name of faculty. And then VLAN 99, you give it the name of native VLAN. To be able to create these VLANs, this is what you're supposed to do. I'll open switch 1. I'll open switch 1. Under switch 1, what I'll do is mine is under the greater sign. So under the greater sign, I'll say enable to move me out of the user executive mode. From the user executive mode, I'll move again now to config T so that it moves me out of the privilege to the global configuration mode. Under the global configuration mode, I'll say VLAN 10, not int VLAN 10. There are different names that we can, there's different levels under this naming. So for example, we have VLAN 10, I'll press enter. You'll be able to see switch 1 config VLAN. Here is where I can be able to say name student. Here is where I can say name student. I'll exit and then I'll say interface VLAN 10. Remember, the command is under the global configuration mode. I did do an exit to move me out of the sub interface of VLAN 10. And then once I was out of the sub interface of VLAN 10, I was taken to the global configuration mode. Under the global configuration mode, that's where I stated interface VLAN 10 and then I press enter. Under interface VLAN 10, I can assign an IP address. But under VLAN 10, I won't be able to assign an IP address. I can only assign a name. So these two commands must be executed. Remember where we assign an IP and where we normally assign a name. At the current lab, we are not assigning IP addresses. We're just creating VLANs. These two commands will assist me to create a VLAN, and then I'll exit. I'm done creating VLAN 10. Questions? I was asked. So yes, you have created VLAN 10. I've stated the name is student. I've exited and then stated interface VLAN 10. These two commands are talking about the same thing. So don't get it wrong. I'm under the global configuration mode. I can start with int VLAN 20. I can start with that. You won't be able to see any pop-ups saying VLAN 20 is up. I'll exit, I'll get out of that sub interface because you can be able to see config if as the same that you got under int VLAN 10, you got a config if. I'll exit out of that sub interface to take me back to the global configuration mode. And then under the global configuration mode, that's I'll say VLAN 20. Immediately I press enter. So there's a difference between int VLAN 20 and VLAN 20, but both of them serve the same purpose of bringing up VLAN 20. Press enter, you'll see now a pop-up. So there's no particular order in creating a VLAN. You can either start with int VLAN 20 or VLAN 20. So this time I've started with int VLAN 20 and then VLAN 20. Under VLAN 20, that's where I'll assign a name. Name is what? Faculty. Enter. Yes. And then I'll exit the sub interface of VLAN 20. VLAN 20 is under the sub interface of config VLAN. It's under the sub interface of config VLAN. The same with VLAN 10. When I started VLAN 10, I was taken to config VLAN. If you check, when I went to int VLAN 10, I was taken to config if. There are two sub interfaces, two separate sub interfaces. We have the config VLAN and we have the config if. If I was making my notes, this is what I would have done. I'll have opened a notepad, I'll have requested for a notepad on my machine, and then under my notepad, I'll have stated switch 1, I'll type switch 1, yes, switch 1, and then I'll say enable. It is now set to be switch 1, switch 1, it will into brackets, greater sign, enable, and then I'll also say switch 1 hash. Where is the hash? Okay, hash. And then I'll say config T. That's the command I wrote. And then switch 1 into brackets, config, yes, config, and then hash. And then this is where I state int. I just started int, I started on VLAN 1. VLAN what? VLAN 10. And then we're taking it to switch 1 into brackets, config, config VLAN, and then on the config VLAN, then this is where now I say hash, this is where now I say name, I say students. This is how we normally do our documentation. So it's a config VLAN, this is where by now I say exit. Under exit, it will take me to switch 1, config, hash, and then this now out of the sub interface of config VLAN, and then I say int VLAN 1, not 1, VLAN 10, and then it will take me to switch 1. Config, there's a pop-up, so remember, config.
Yes, sir. I just copy from my notepad in CLI straight to my notepad for notes.
Okay, for me, I'm vast. I know the commands, so it's good to practice also to know the commands. So I'll say yes, it will take me to config, and then I'll exit, and then it will take me to switch 1, and then I'll say config.
Because in the evening when I'm practicing, I want to take the same step one by one, one by one.
Yes, that's good.
Okay.
So I'll say after that I'll say VLAN what? VLAN 20, and then to take me to switch one. So if you're a guru, you find now gurus doing this. So this is what we normally do. I copy, I paste it down there, see, down there. I remove this other blah blah blah, blah blah blah. Yes, yes, this is how we do it. Time you get, you'll be able to do, not gurus, just people who have been redoing the configuration for a period of time. So they're able to see, they're able to know what to do. This is what we normally do. So VLAN one. So we have stated the VLAN 20, then we say faculty, and then int exit. I already know what will happen. Int what? VLAN 20
And
exit, and then I say sorry, so I say VLAN, I say VLAN 30, man is what? Man is not 30, it's VLAN what? 99, man is 80, and then I exit, and then I say int VLAN 99, and then I say end, and then I say right, and then if I've already done it 20, so I'll just copy for 99, so copy, and it's, then I've already written, I've already configured the entire thing. So yes, those are some of the shortcuts, those are some of the things that you'll be able to do by the time I'm done with you guys.
Joshua, where is your notepad or copying?
Everything you did on switch one, you have to come and do it on switch two. So you just open switch two, and then you configure everything, and you save. Remember to do what? To save. So you type VLAN 10, name is student, exit, you say int VLAN 10, and then exit, you say VLAN 20, and name is faculty, int VLAN 20, and then because I've just pasted the commands, you'll be able to see the pop-ups came later on. So VLAN 10, 20, and 99. So do that, configure VLAN 10 to 99 and 62. Case sensitive on the names. So if you use caps, you have to use caps. If you use small caps, you have to use small caps. To be able to see what you have done under switch one, you just type the command show VLAN brief, and then you press enter. And then you press what? You press enter. It will be able to show you the VLANs that you have created, VLAN 10, VLAN 20, and VLAN 99. The names that you had used, there's the student, there's the faculty, there's the native VLAN, yes. VLAN 10, 20, and 99. Again, you can be able to see no interface is associated with the VLANs. So yeah, there are no interfaces associated with the VLANs. So we're going to move the interfaces to their correct VLANs later on. If yeah, that's one of the mechanisms you can use to check on your VLANs. So the next step is to move PCA to VLAN 10, PCB to VLAN 10, PCC to VLAN 20. Remember, the PCs are not associated to any VLAN physically. We haven't told them about any VLAN. Only the switch understands VLAN. And to move PCA to VLAN 10, we have agreed we move F06 to VLAN 10. Why? If you type show VLAN brief on switch 1, you'll be able to see all interfaces are under VLAN 1. But you have already created VLAN 10, 20, and 99. To move F06 to VLAN 10, that's what we want to learn, how to move a device to a specific VLAN. So we don't move the actual device, we normally move its interface that it's connecting to the switch. So I'll start with switch 1. I'll say config terminal, and then I'll say int F06. You can type interface fast Ethernet 0/6, or you can just use the short form interface or int F06. By default, it's under VLAN 1, but before we even move an interface, we now need to talk about switch port. We normally say mod space question mark switch port, mod space question mark. All Cisco switch interfaces belong to mod dynamic. All switch interface on a Cisco device belong to switch port mode dynamic. All other versions of switches do not have this option. They only have access and trunk. But on our switches, on our Cisco switches, they normally have dynamic. What's the meaning of dynamic? If I was to type dynamic space question mark, you'll be able to see several options, auto and desirable. Our interfaces are usually under mode auto. They usually switch port mode dynamic auto. That's the mode that they're usually under. What's so special about being under mode auto? It just waits. Auto is the mechanism of waiting. If the other side becomes access, it activates the access functionality on this side. If the other side is trunk, it makes itself trunk. If the other side is desirable, it makes itself trunk. So auto just waits to be told what to become. So yes, but right now we are not dealing with switch port mode dynamic. That one is for later on. We shall explain it later. It's just an honorable mention. Right now we have access and trunk. When you're connecting two switches, we normally use switch port mode trunk when you're connecting two switches. Why? We want that same cable to carry multiple VLANs. Trunk allows an interface cable to carry multiple VLANs from one switch to the other switch. Right now, we are not connecting to another switch. We are connecting to a PC. Interface F06 is connecting to a PC. And if F06 is connecting to a PC, which command are we supposed to type? We are supposed to type switch port mode access, meaning what? This device is connecting to an end, this interface is connected to an end device. May it be a printer, may it be a desktop, or may it be a PC. So whenever an interface is connecting to such a device, yes? So as I was saying, when
Hello?
switch port mode access is used to connect to end devices. So when this interface is connected to an end device, we normally use switch port mode access. So that's the command, switch port mode access. So on switch one, those are the commands that we wrote to create um, the VLANs. So on switch two, we also use the same commands, remember. So now I'm saying, so I'll type, I'll remove this, so exit. So under switch 2, we have gone to, under switch 1, we have gone to int F06, and then we have stated switch port, mode access, plus the command that we have typed under switch, uh, under switch 2, under switch 1, sorry. And then after that, the second command is switch port access VLAN 10. So this command won't be of any use if we didn't type switch port mode access. So switch port mode access becomes the first tool because you can't move an interface to a specific VLAN if that interface is under auto. You have to first of all move it to access. Once the interface is under access mode, now you can move it to a specific VLAN. You can't move an interface to trunk and then assign it to a VLAN. Trunk means it can carry multiple VLANs. So you can only lock an interface that is going to a PC or a desktop to a specific VLAN. But a cable connecting to a switch, you want it to carry multiple VLANs. We shall explain that further as we continue. But the command is switch port access VLAN 10. So do that on that switch. Once you're done configuring that, now we can move back to our topology. We can move back to our topology. On a topology, we confirm the cables are still green. Yes. If yours is amber, it means you're still moving the interface to that VLAN. To confirm, you can slide your cursor to the switch. You can slide the cursor to switch 1. You'll be able to see F06 is going to VLAN 10. So you'll be able to see F06 is under VLAN 10. So yes, I'll place the cursor under F06. You'll be able to see VLAN IP address link. The link is up. That's the first thing. VLAN that interface is associated with is VLAN 10. You can also be able to see VLAN 10, 20, and 99 were created. VLAN 1 has an IP address. MAC addresses under each VLAN. So you'll be able to see MAC addresses under each VLAN. Yes. So away from that, I'll continue. So now we can test if PCA is under VLAN 10. PC boy is still under the default configuration. So we shall ping from PCA to PC boy. So open PCA and then go to desktop and then command prompt, PCA desktop and then command prompt, and then you ping 192.168.10.4 and then you ping 192.168.10.4. Remember last time it was successful. This time it's supposed to fail and I need to know why they are failing. Yes. So to see if PC A has been moved to VLAN 10, we say show VLAN brief. We say show VLAN. Under show VLAN brief, you'll be able to see F06 has been able to move to VLAN 10, which is student. So this will limit. So when PCA tries to ping, PCA tries to ping PC boy, it won't be successful because PCA is under VLAN 10 and PCB is under VLAN 1. We haven't yet moved PCB to VLAN 10. So we need now to move PCB to VLAN 10 and PCC to VLAN 20 because you're on the same switch. So you can do both of them instead of doing them separately. So now we need to move to switch 2. We move switch 2 to PC boy under switch 2 to VLAN 10. That's the reason why we created the same VLANs on both switch 1 and on switch 2. So we'll open switch 2. Under switch 2, I'll say enable config terminal. Remember on which level we normally configure interfaces. I shall say int F011. Remember, PC boy is connecting to the switch via F011. So F011 is the interface connecting to PC boy. So we have to move it to VLAN 10. So the first command is switch port mod access. Remember, we can't move any type of an interface. That interface must first of all be an access port. So we explain to the switch this interface is an access port. After that, we say switch port access VLAN 10. So the second command moves it to VLAN 10. And then you say end, and then you say write. You save your work. Yes. So that's the first step to move it to VLAN 10.
Just watching.
Personally, yeah.
So now we can say show VLAN brief, show VLAN brief to confirm F011 has moved to VLAN 10, and yes, F011 has moved to VLAN 10. We do the same for PCC. So I'll say config terminal, and then PCC, remember, it's F018. So
Yeah.
remove F0, remove F018. So I'll say int F018, and then I say switch port mod access as the first command, and then switch port access
Assets
VLAN
VLAN 18
20,
20.
VLAN 20, and then end, and then right, and then I'll say show up arrow to recall my commands up, and until I find show VLAN brief. Enter. You'll now be comfortably able to see F018 has been moved to VLAN 20 and F011 has been moved to VLAN 10. So we have successfully moved PCB to VLAN 10 because it's under F011, and then PC, which is under F018, to VLAN 20. So you have learned three things. You have learned how to create a VLAN. We've learned how to move an interface to an access mode, and then right now we have learned how to move an interface or a device to a specific VLAN. Yes. After you have configured that on switch 2, we can now try to ping from PCA. So you have moved PCA to VLAN 10, PC boy to VLAN 10. So now we want to ping between PCA and PCB. So I'll open PCA, go to desktop, and then command prompt. Under command prompt, I ping 10.4. Under command prompt, I ping 10.4. So what's the result? What are the results that you guys are getting?
Request timeout.
Request timeout. Why? Can somebody tell me why PCA cannot be able to ping PC boy and they are on the same group and they are on the same network? Why? This is now your work as a networker. Yes. Why? This is not the secret in networking that you're supposed to follow. When PCA is pinging PCB, your work is to follow the packet logically. The packet is generated from PCA. It enters the switch via F06. While entering the switch via F06, it will be tagged with a VLAN 10, meaning what? The switch is only allowed to forward that traffic to all devices that are under VLAN 10. So, switch 1, which other interface is under VLAN 10? Which other interface is under VLAN? So there's no other interface under switch 1 that supports VLAN 10. So by default, switch 1 will drop the packets from PCA that were tagged with VLAN 10 because there's no any other interface that supports VLAN 10. So we need to do something on F01 because F01 is under VLAN 1, so it can't receive data from VLAN 10. It will only receive data from VLAN 1. So if we decide to move F01 to VLAN, if we decide to move it to VLAN 10, what will happen? PCA and PCB will comfortably be able to communicate. But what if we had another PC here and the PC was under VLAN 20 and the PC was under VLAN 20, and these two PCs, PC9 and PCC, wanted to communicate? What will happen? They are under VLAN 20 and they want to use the same cable, but this cable is under VLAN 10. Will we be changing the cable to VLAN 10, VLAN 20, so that guys for VLAN 20 can communicate? Once they're done communicating, we move the cable again back to VLAN 10 so that the traffic for VLAN 10 can be able to communicate. No, we won't be doing that. That's not possible. That's not practical. So moving the interface to VLAN 10 won't be an option. The option that we have then is we take the cable, we make the cable a trunk. We make a cable trunk. What do you mean by a trunk? Remember, we had two options. The default one for all vendors. We have the access and the trunk. Access to connect to an end device, meaning that end device can be given a specific VLAN. Trunk means that this interface or this cable can be able to carry multiple VLANs. It means this cable can be able to carry multiple what? VLANs. Yes. So both VLAN 10 and VLAN 20 can be able to share the same cable. So when I say, so we need to learn how to configure this cable as a trunk. To configure it as a trunk, we open switch 1. We open switch 1. And the config terminal, we say int F01, we say int F01, we say switch port mode trunk, switch port mode trunk. On Cisco recommended procedure is what we do on this side, we have to do it on the other side. So we have to say end, we save our work, and then we move to switch 2, and we do the same. And then we move to switch 2, and we do the same. Enable config to int F01, and then we say switch port mod trunk. So this is what we have done. Write it on the notepad. So under switch 1, we stated F01, F01, switch port mode, only that, and then we ended, and then we saved our work. So this is the command. The same procedure, because we are still connected to the same interface on switch 2. But if you are on a separate interface, you'll have chosen that interface. So int F01 switch port mode trunk. That's the command that you're typing on both sides. Switch port mode trunk on both sides. Do that. So as the data explained, data to move from PCA to PCB, it will enter switch 1 via F06. F06 belongs to VLAN 10. It will be broadcasted to all interfaces that support VLAN 10. F01 supports all VLANs. So data will move from switch 1 to switch 2. Switch 2 will look for, with the tag of VLAN 10. Switch 2 will look for all interfaces that support VLAN 10. It will say it's only F011. So the tagging information will be left under F011 and the data moves to PC boy. PC boy will acknowledge. To acknowledge, it becomes the source. PCA becomes the destination. When the data is entering switch 2, it will enter via F011, where it will be tagged with VLAN 10. So the data now can move from switch 2 to switch 1 via F01, because F01 is the only interface that supports VLAN 10. F018 won't get that packet. So the data will move to switch 1. Under switch 1 will check any interface that supports VLAN 10. F06 becomes the interface. So the tagging information is left on the switch. That is not taken to the PC. So the tagging information is left there, data moves to PCA, and PCA gets its own acknowledgement. And that's how the ping becomes successful. We can test, we can ping from PCA to PC boy, and it will be successful. Yet again, PCA can and will not be able to ping PC cat, because PC cat is on a different group under the VLAN information, and again it's under a different network, so totally they cannot be able to communicate. Yes, so that's the first segmentation level that we normally do. Questions? We've already used VLAN 10, we've already played with VLAN 20. Now you might ask yourself, where are we going to use VLAN 99? VLAN 99 is used for, we normally use it as the native VLAN. The native VLAN by default is VLAN 1, but we normally move that functionality to VLAN 99. Basically what I mean is we want VLAN 99 to carry all untagged frames. Remember, we have certain functionalities on the switch that we, like the CDP, Cisco Discovery Protocol, network time protocol. We have certain protocols that are running on the interfaces between switch 1 and switch 2 that are not generated from any other interface. Remember, the other interfaces are placed under certain VLAN, but data coming from switch 1 to switch 2, they're not under any other VLAN. So you might find untagged frames. Untagged frames will be carried by VLAN 99. So that's what we want to create. We want to make it the native VLAN to carry all untagged frames. So it's like saying the way you normally have a public transport. So trunk is a highway that allows any type mode of a vehicle to utilize the highway. But if you do not have a mode of, you don't have a vehicle, then you can't be able to utilize the highway. So, and if you want to utilize it, you can use the public service vehicles, the PSVs. So Villa 99 becomes the PSVs for all untagged frames. To be able to do that, we normally go to the trunk. We normally go to the trunk. So enable config terminal under switch 1, config terminal, and then I'll say int F01, that's the trunk table, and then I'll say switch port, trunk native VLAN 99. This one now means anybody who's not tagged and wants to utilize this interface, we are going to carry their data under VLAN 99 to the other side. But remember, the native VLAN by default is usually VLAN 1, but we normally move that functionality to VLAN 99. So that's the command that you normally use. It's not a must to use VLAN 99. You can choose any other VLAN, but most of the networkers normally use VLAN 99 as per Cisco recommendations. So we say enter. The reason why we're getting mismatches on this side is because switch 1 understands that the native VLAN is VLAN 91, 99, and switch 2 understands the native VLAN is VLAN 1. So we need to save our work on switch 1 and then move to switch 2 and explain to switch 2 that we have agreed. So it's enable config T that we have agreed under the trunk table, which is int F01, that the native VLAN will be VLAN 99. Yes, the native VLAN will be VLAN 99. So I'll end and then save my work. WR is the short form for write. I'll save my work. And then I'm supposed to get a pop-up of being resolved. If I won't get the pop-up on switch 2, I'll check on switch 1 if I got the pop-up that the mismatch has been resolved. Yes. Here it is. Yeah. I'm blocking consistent port. I'm blocking F01 on VLAN 1 port consistency restored. VLAN 99 port consistency not restored. Yes. So it means now we are working at 100% sanity. They are working okay. So that's how you do it. So native VLAN, remember, normally carries all untagged frames. So it's our public vehicle now to carry all untagged frames. So on a trunk cable, a trunk interface can be able to carry any type of VLAN. So we want to permit or deny certain VLANs on a certain trunk interface. We can say switch port trunk allowed. On the trunk interface, remember, on switch 1, you're on switch 1, switch port trunk allowed VLAN. So you can say 1, 10, 20, 99. So this will mean that only this trunk cable will be allowed on that interface. So press. So I can exclude maybe 99. I can exclude maybe 99. So I can say switch port trunk allowed VLAN 1, 10, and 20. It will mean VLAN 99 would be allowed under this cable. To add it, I can just say switch port. I can redo the entire command, but if I don't remember the VLANs that are allowed, I can check it, or I can say allowed VLAN. I can say add 99. Think so, yes. So that's how we add a VLAN on the list of the VLANs that were to be permitted. So you say switch port, trunk, allowed, VLANs, blah blah blah, blah blah blah, and the other one. So that's how we do it. So under switch one, yes. So I've written that's the command, and then switch port, trunk, native, VLAN, 99. Yes. So these are the commands that we have done in the those interfaces. So we can even say switch port trunk allowed VLAN except we say VLAN what? Maybe 10, or that way we can remove a certain VLAN. So those are the commands we normally play with. So this is the same information that we're supposed to have on switch 2. So move to switch 2 and do the same. Move to switch 2 and do the same. Move to switch 2 and do the same. Yeah. So I'll go to switch 2, I'll go to switch 2, and then I'll add that command. Config int f01. Because I'd already done switch port in the trunk, I don't really need to do that. I would already done switch port trunk native VLAN 99. I don't really need to do that. I just say switch port trunk allowed VLAN 1, 10, 20, and then what? 99. And then save my work. And then save my work. So do that in 62 also.